Okay, we left with the last this thing today of equilibrium. There are 6 questions. We've done 2 formula, one was Henderson equation and one was salt hydrolysis. We're just going to discuss a few questions in that section. Let's go on to question number 1. The first question is, calculate the pH of buffer solution containing 0.15 mole of NH4OH and 0.25 mole of NH4Cl, Kb for NH4OH, that is 1.98. Now this is going to form a basic buffer over here, ammonium hydroxide and ammonium chloride. So the equation which we are going to use, that is POH, that is equal to pKb plus log of concentration of salt upon base. Okay? So this is going to be the equation which we are using. Now when we are talking of pKb can be written as what? pKb, that is equal to minus log of Kb. So the above equation now becomes POH, that is equal to log of concentration of salt upon concentration of a base minus log of Kb. Okay? They have given us the concentration of both. The concentration of NH4Cl, that is given as 0.15, and that of the salt it is given as for NH4OH it is 0.15 and for NH4Cl it is 0.25. So we have over here log of concentration of salt which is given as 0.25 upon 0.15 minus log of Kb. So minus log of 1.8 into 10 raised to power minus 5. Okay? So let's calculate this over here. How can we do this? We have over here 5 5s and 5 3s. Okay? So this can be calculated as log of 5 minus log of 3 minus log of 1.8 into 10 raised to power minus 5. Now the value of log of 5, that is 0.6989. So we put the value. Log of 3 has a value of 0.4771. Okay? And iski jo value aayegi, minus and minus, that is going to become plus. Okay? So 5 minus log of 5 into log of 1.8. Okay? So the value over here that comes to 4.7448. 4.7448. Now when we calculate this entire term, the POH that comes to 4.966. So what is going to be the pH then? 14 minus 4.966. Okay? And that is going to be equal to 9.034. So it's a very simple kind of a question. By just putting in the values of all in the equation, you can easily calculate it. Okay? Let's go on to question number 2. What is question number 2? Question number 2 is, how many gram moles of HCl will be required to prepare 1 liter of a buffer solution containing NaCl and HCl of pH 8.5 using 0.01 gram formula mass of NaCl. Ka for HCl, that is given as 4.1 into 10 raised to power minus 10. Okay. Now if we are adding 1 mole of HCl to NaCl, what is going to be the equation? NaCl plus HCl. This is what we are doing. Okay? This is going to give us NaCl plus HCl, right? To solution of NaCl we are adding this. Now let's say that the number of moles of this is A, number of moles of this will also be A, this will also be A, and this will also be A. In a balanced equation, all there are one number of moles is present. Okay? Then what is going to be the concentration of NaCl? The initial concentration of NaCl, which is given to us, that is 0.01. Using 0.01 gram formula mass of NaCN, that is what is given to us in the question. So concentration of NaCN, that will be equal to 0.01 minus A, right? And what is going to be the concentration of HCN formed? The concentration of HCN, that is going to be A. Okay? Now how do we calculate the pH? pH is equal to log of concentration of salt upon concentration of acid minus log of Ka. Okay? So let's put the values over here. pH is given to us in the question as 8.5. So we have to calculate A over here. That will be equal to log of concentration of the salt, that is 0.01 minus A upon A, okay, minus log of Ka. So Ka is given to us as 4.1 into 10 raised to power minus 10. Okay? So what are we going to get over here? Therefore log, you have to get that this side, on this side, log of the value of log of 4.1 into 10 raised to power minus 1, that is going to come as, let's see what is it coming, log of 4.1 can be taken as log of 4. Okay, so we are getting this side, or you can solve it on that side only first. So here आएगा log of 0.01 minus A upon A, that is equal minus log of 4.1. Let's take it as log of 4. Okay, so minus plus आ गया यहाँ पे 10 minus log of 4 has a value of 0.6020. ठीक है, so this will come as log of 0.01 minus A upon A, and 10 minus this will be 0.893 9.3980. ठीक है, so this is going to be the value which we are going to get over here. Now when we are talking of this value, now how do we calculate the value of A over here? How will we calculate the value of A over here? We first get this on the other side. So we have log of 0.01 minus A upon A, that is going to be equal to 8.5 minus 9.3980. So this is going to come as 9.8 and 9 and 13 negative 5 is 8 and 0.8980 minus, is this going to be the value? ठीक है, so minus 0.8980. Let's do the calculation once again. We should take a chance over here. So we have this minus 8.5, 0, 8, 9, 13 negative 5 is 8, 0.8980. ठीक है? Now in order to calculate A, 0.01 minus A upon A, that is going to be NT log of minus 0.8980. ठीक है? So can I have the log tables? NT log of 0.89 has to be calculated over here. The NT log of 0.89, that is 7762. So there is minus over here. How do we do it? Minus 1 plus 1 minus 0.8980. ठीक है? So ये क्या आ जाएगा? This will be equal to minus 1 plus या point, 10 away 0, 2, 0 and 1, ठीक है। और जो डेसिमल से इस साइड को होता है वो क्या चला जाता है 10 raised to power -1 and we have to take the empty log of 0.10 under 2. Empty log of 0.10 under 2, it is coming as 1265. So 1.265. Right? So now can you calculate A from here? 0.01 minus A upon A, that we are getting as this. So I'm going to rub this side of your question. We are getting this equation 0.01 minus A upon A, that is equal to 1.265 into 10 raised to power -1. Can we write it like this? 0.1265. ठीक है? So what will we get? 0.01, that is minus A, that is equal to 0.1265A. ठीक है? ये उस साइड चला जाएगा, so 0.01, that is equal to 1.1265A, और 0.01 divided by 1.1265, that is going to be the value of A. ठीक है? So it comes to 0.0089 moles. So this is the amount of HCl that should be added. This is what they have asked in the question. How many gram moles of HCl should be added? So when A is coming as 0.089 moles and we have taken the concentration or the number of moles of HCl as A, therefore 0.0089 moles should be added to make the required solution. Is it clear? So this is how you were supposed to do this question. Let's go on to our next question now. What is our question number 3? Calculate the hydrolysis constant for NH4Cl. pH value at OH, concentration of OH in 0.1 molar NH4Cl solution when K for NH4OH is given as 1.75 into 10 raised to power -5 and Kw is 1 into 10 raised to power -14. Now when we are talking of this solution, this salt over here, NH4Cl, this is going to be a salt of a weak base and a strong acid. ठीक है? So what is going to be the value of KH for a weak base and a strong acid? That is going to be equal to Kw upon Kb. The value of Kb they have given to us as, we know it also, it's 1 into 10 raised to power -14. And the value of Kb given to us is 1.75 into 10 raised to power -5. Okay, so when we calculate this, the value of KH that is coming as 5.7 into 10 raised to power -10. Right? The second thing which we have to calculate over here is the pH value and concentration of OH negative. So let's calculate the pH first. What is going to be the pH? What is the formula of the pH which we are going to use over here? pH that is going to be equal to, either you can calculate the concentration of H positive ions or you can directly calculate the pH over here. That is going to be equal to 1/2 log of Kw. Is concentration given to us? Yes, it is given, 0.1 molar. So 1/2 log of Kw minus 1/2 log of Kb minus 1/2 log of C. Right? So we have over here 1/2 into log of Kw. Kw has a value of 10 raised to power -14. So we will have over here 1/2 into 14. ठीक है? So which can be directly written as 7. So we can write this as 7 over here. Minus 1/2 into log of Kb. Kb is given to us as 1.75 into 10 raised to power -5 and minus 1/2 into concentration of log of concentration. Concentration given to us is 0.1. So this will come as 7 minus, इसको कैंसिल करो, 0.8, 16, 15 means 0.875 आएगा ये, ठीक है. So minus 0.88 ले लेते हैं इसको into 10 raised to power minus 5, and this is going to come as minus 0.05. ठीक है, 0.05. So when you calculate the pH over here, that comes to 5.12. The pH that will be calculated as 5.12. Even if you're taking the concentration of log of H positive, then also you can calculate, or you can also calculate as this. So pH comes to 5.12. Now over here we need to calculate the concentration of OH negative. How will you calculate that? That will be calculated, you know that concentration of H positive into concentration of OH negative, that is equal to Kw. Okay, so यहाँ पे आपको H positive की concentration in any case calculate करनी पड़ेगी. So how will you calculate that? You know that KH, that is equal to Cx square upon 1 minus x. This is the formula which we use. Okay, so what is the value of KH? We calculated the value of KH, that is 5.7 into 10 raised to power minus 10. That is equal to concentration given to us is 0.1. ठीक है, so इससे पहले आप x square calculate करो कितना आता है, because x is going to be very very less, so this can be ignored. So we will have 0.1 into x square. So 5.7 into 10 raised to power minus 10 upon 0.1, that is going to be x square. ठीक है, so ये आपका कितना आ गया, 5.7 divided by 0. This can be written as what? 57 into 10 raised to power minus 10, right? So x will be equal to what? Under root of 57 into 10 raised to power minus 10. Okay, so the under root of 57, that is 7.5. So the value of x comes as 7.55 into 10 raised to power minus 5. And this x is going to be the concentration of H positive. So you can either calculate the pH value directly by taking that 7.55 into 10 raised to power minus 6. Concentration of H positive will be what? Cx. We've taken it now, but then the concentration is going to be Cx. So either you take the concentration of H positive from this, therefore concentration of H positive, that will be equal to 7.55 into 10 raised to power minus 6. ठीक है, that is 7.55 into 10 raised to power minus 5 into 0.1. So that will be 7.55 into 10 raised to power minus 6. So what is going to be the concentration of OH negative then? Kw upon 7.55 into 10 raised to power minus 6. So when you calculate this, it comes to 1.32 into 10 raised to power minus 9. into 10 raised to power minus 9. Okay? Then let's do the next question. Question number 4. The question is, calculate the amount of ammonium chloride required to dissolve in 500 ml water to have a pH of 4.5. Kb for NH4OH is 1.8 into 10 raised to power minus 5. So first of all, we will have to calculate the concentration of H positive over here. We know that pH, that is equal to minus log of concentration of H positive. ठीक है? pH is given to us as 4.5. ठीक है? So 4.5, that is equal to minus log of concentration of H positive. To calculate the concentration, we will take NT log. So we have NT log of minus 4.5, that is equal to concentration of H positive. तो यहाँ पे वो सेम लगाओगे आप, -4 -1 +1 -0.5, इसका आपको NT log लेना है to give us the concentration of H positive. So ये आ जाएगा -5.05, 1 minus 0.5, that is going to be equal to 5.5. ठीक है? So we take the NT log of 0.50 over here. The NT log of 0.50 is 3162. Okay? So that will be concentration of H positive, that is equal to कितना था 3162. 3162. So 3.162 into 10 raised to power -5. So here we are getting the concentration now. So now we are going to hit the same formula over here. What are we going to calculate? Calculate the amount of ammonium chloride required to dissolve 500 ml of water. We have to put over here. Now you know that the hydrolysis constant Kh, that is equal to what? Ch square. Cx square हमने पहले लिया था. We are taking this as Ch square. So let's calculate the value of Kh over here. Kh will be equal to Kw upon Kb. Ch square, the value of Kw is 1 into 10 raised to power -14. The value of Kb is given to us in the question, 1.8 into 10 raised to power -5. That is equal to Ch square. So when you calculate this, this comes to 5.5 into 10 raised to power -10. 5.5 into 10 raised to power -10, that is going to be equal to Ch square. So what is going to be the value of concentration? हमको कितनी दी है इन्होंने? They have not given us. Have they given us the concentration? We've calculated the concentration of H positive. Now that is going to be what? 3.162 into 10 raised to power -5 we have calculated. So we have to calculate H over here. Okay. So how do we calculate H over here? That will be equal to 5.5 into 10 raised to power -10. upon CH, that is equal to H, because ये जो CH है ये concentration of H positive आएगी. Cx was the concentration of H positive, so similarly Cx is the concentration of H positive over here. तो यहाँ पे CH आ गया और H हमने ऊपर ही छोड़ दिया. So let's put down the value upon C. क्या आ रही है हमारे पास concentration? 3.162 into 10 raised to power -5. That is going to be the value of H. Okay. So when you calculate this, it comes to 1.739 into 10 raised to power -5. That is the value of H. ठीक है? So now you need to calculate the value of concentration. You know that the value of CH, that is equal to what? 3.162 into 10 raised to power -5, and the value of H is equal to 1.739 into 10 raised to power -5. So concentration will be equal to 3.162 into 10 raised to power -5 divided by 1.739 into 10 raised to power -5. So ये दोनों कट गए. Okay, so this will come to approximately 1.8 moles per liter. But we have to find the concentration in 500 ml. So 500 ml में concentration कितनी हो जाएगी? 1.8 divided by 2. That comes equal to 0.9 mole. Okay, in 500 ml. And grams में if you need to calculate, because they've asked us to calculate it in grams. So NH4Cl का आपको molar mass निकाल के and then you multiply it by 0.9 and you get it in this thing in grams. ठीक है? So these are a few of our questions. Only these were there ना 4 questions. 6. So दूसरे कौन से हेंडरसन इक्वेशन वाले? I think these 4 are enough. The other 2 are very easy. Suppose it is required to make a buffer solution of pH is equal to 4 using acetic acid. They are easy questions that you can do on your own.